All right, today we're going to be reviewing your slope formula that you guys learned in 7th and 8th grade. We have the general formula for slope when you're given 2 points. M equals y2 minus y1 over x2 minus x1. I believe you guys have seen this before. So what I'm going to do is go ahead and model a couple of examples for you and explain a couple of important ones. Your assignment's going to be to finish up these notes and then to finish the assignment that I gave to you, which is page 73, I believe, on the counter, but you'll get that later. So let's start with example 1. We're asked to find the slope of the line given the points. So what we're going to do first is we're going to label each point. We have our first x value and our first y value. We'll call those x1 and y1. Then we have our second x value and our second y value. We'll call those x2 and y2. Those are subscripts. They're numbers on the bottom of the number. They're not exponents. So don't write them like exponents either. Don't bring them up. Because they're telling you that you have more than one kind of number, and we're calling one of them x1 and x2, and the other one's y1 and y2. Next step, let's go ahead and write the slope formula down. Slope, which is m, equals y2 minus y1 over x2 minus x1. To find the slope between 2 points, it's pages 71 and 72. To find the slope of 2 points, let's go ahead and substitute in all the things we know. So I'll start a fraction bar. What is y2 according to our points? 8. Minus, what is y1? 3. On the bottom, what is x2?
4.
And minus, what is x1? Negative 2. So I'll put that in parentheses, so that way I don't get confused between the subtraction sign and the negative sign. Now let's go ahead and just do the math. On the top, what is 8 minus 3?
5.
And on the bottom, verify with your calculator too. 4 minus negative 2. 6. Can 5, 6 be simplified any?
No.
No. So 5, 6 is our slope, and that's our answer. Stop there. Let's try this again now with number 2. If you have the hang of it, feel free to get ahead of me. Slope, I'll first label my points. x1, y1, x2, y2. Slope formula is y2 minus y1 over x2 minus x1. And I'm going to fill in, bless you, my values. y2 is positive 2. y1 is negative 6, which I'll put in parentheses to separate the subtraction from a negative sign. On the bottom, x2 in parentheses is negative 5 minus x1, which is positive 7. So now if you guys will help me out, in the numerator, what is 2 minus negative 6?
1.
I don't see how that's possible.
Wait.
8.
8, thank you. And on the bottom, what's negative 5 minus 7?
Wait, what did I do?
12. Negative 12.
Negative what?
12.
Negative 12. Can this fraction be simplified?
Yes.
Oh.
Yes, now with your calculators, it'll actually simplify for you. If you type in 8 over negative 12 and just press enter, it'll give you the simplified form.
I got 12 on the calculator. Why is it negative?
Negative 5 minus 7 more, did you put the negative 5 in parentheses? Probably not.
Oh, okay. That's fine. 8.
So what do we get when we simplify negative 8 twelfths?
Negative 2.
Negative 2/3 or negative 2 over 3. Quick side note, when you have a negative fraction, technically the negative sign needs to come outside of the fraction. The negative is not necessarily assigned to the 2 or to the 3, it's assigned to the entire fraction. So kind of pull it out to the side separately, which is going to actually come into play very soon at the end of these notes, or towards the end of these notes. So I'm going to go ahead and move on. Actually, no, I need to do number 3 and 4 now. I thought I had more examples than that for these kind. So 3 and 4 are special cases now, so let's go ahead and put a little star around them, and let's explore what's going to happen. Whoops, keep moving this around. All right, so let's go ahead and label our points again. x1, y1, x2, y2. And also, let's set up our slope formula. M equals the fraction y2 minus y1 divided by x2 minus x1. To find our slope now, let's fill in all our values. So what is y2?
2 minus 2.
2 minus y1, which is also a 2. 2 minus 2. And on the bottom, what's x2? 5 minus 1. So let's go ahead and figure this out. What is 2 minus 2?
0.
What is 5 minus 1?
4.
So, in your calculator, go ahead and do 0 divided by 4 and tell me what it says.
0.
0.
So you have a slope of 0. Whenever 0 is in the numerator, no matter what number is in the denominator, your slope is just 0. Now let's find out what happens with number 4. This is also a special case. So I'll put a star on this. And let's go ahead and label the points. x1, y1, x2, y2. Slope formula. y2 minus y1 over x2 minus x1. Let's fill in our values. What is our y2? 5 minus 1 on the top. On the bottom, we have 2 minus 2. Simplify this fraction for me. 5 minus 1? 2 minus 2?
0.
Look at your calculator. Do 4 divided by 0 and see what it says now.
Undefined.
Undefined. So whenever you have a 0 on the bottom, your answer will be undefined. That means you're going to have a line that's straight up and down. So an undefined line is going to look like this, straight up and down. Guess what a 0 slope looks like? Exactly, a flat horizontal line. So if you see those on a graph, automatically, you don't even have to calculate. You'll know exactly, you just call them that. Perfectly flat line, 0 slope, perfectly up and down one is undefined. Any questions on these first 4, class?
No, sir.
All right, let's go on to the next 2. Here's where we actually get to the algebra 1 part. And it's really not even that much complicated. So now they want us to find the missing value for the line that goes through the given points and the slope. So we have points again, and they did the slope for us. So let's label the points x1, y1, x2, y2. That's a good first step. x1, y1, x2, y2. And then let's go ahead and write the formula for slope again. M equals y2 minus y1 over x2 minus x1. Now, from left to right, that's me, we're going to go ahead and fill in all the things we know. Do we know what the slope is?
Yes.
What is it?
1/5.
It's 1/5. So I'm going to start off with a 1/5. And then line up my fraction with that same fraction bar from the 1/5. And let's fill in our values now. What's y2?
5.
Minus what's y1?
4.
What's x2?
R.
R. Minus what's x1?
-2.
Okay, so now, let's verify the math where we do have actual math that we can check. In the numerator, does 5 minus 4 indeed equal 1?
Yes.
That does equal this, so we're good there. So then what we need to do is solve the bottom part. What we have on the bottom basically is 5 is equal to r minus -2. So some number minus -2 will give me 5. Does anyone remember the trick when you have a minus and a negative? It becomes plus and adding, or positive and adding. But it still doesn't give us the answer yet, but it makes it a little easier to see. R, a mystery number, plus 2 more would equal 5.
3.
So R has to equal 3. You could also just end solve it if it's too complicated. You could type in 5 equals R minus -2, comma R, and then get your answer that way. Let's go ahead and move on now to number 6. Same exact thing, label everything again. x1, y1, x2, y2, and then there's our slope. Then write the slope formula. Slope M equals y2 minus y1 over x2 minus x1. And let's fill in everything we know starting with the slope. What's our slope?
R minus, oh wait.
Negative 3.
-3/4. So here, what I tell you about writing negative fractions,
Oh, put it like outside.
pull the sign outside of the fraction. So write it as -3/4 3 over 4 like this with a negative sign on the outside. And you're going to see why exactly right now that is so important. Equals, fraction bar, let's fill in our values. What's y2? R. What's y1? 4. On the bottom, what's x2? Negative 1. Minus 3. So now, here's the question. It looks like, if we just went by looks, that the 3 carries the negative sign, right?
Yeah.
It looks like that. That's the way it's written in the problem. But the way I told you to write it, we really don't know. So where do we have math that we can actually solve? In the numerator or in the denominator? Denominator. So with your calculators, tell me what is negative 1 minus 3?
Negative 4.
So then where is that? So then what number gets the negative sign from this fraction?
4.
So negative 4. So this will all go together. So then here's the equation on top I have to solve. 3 is equal to r minus 4. Some mystery number, take away 4, will give me 3. Some mystery number, take away 4, will leave me with 3. So do you see why the negative, we have to figure out where that negative sign goes first? Because if you put it on top, you would have gotten a totally different answer. So what we did is we took the math in the denominator that we know how to do, and we verified where this negative sign actually goes to. Because it looked like it went with the 3 up here, but it really, we didn't know until we figured it out. All right, let's get to the next page. It's going to go a little faster from here on out. So slope is also called the constant rate of change. And there are a couple of ways we can do it. When you're given a table, we can still do the slope formula. So let's pick a pair of points from number 7. Pick any one to be our x1 and y1.
6 and 10.
Okay, so we'll call this x1 and this y1. Now pick another pair of points to be our x2 and y2. 9, 16, fair enough. x2, y2. And you can really pick any 2 points in any order you want, as long as x goes with the y and the x2 goes with the y2. Let's do our slope formula. I'm going to jump right into filling everything out. What's our y2?
16.
What's our y1?
10.
On the bottom, what's our x2?
9.
And our x1?
6.
Oops, that's a minus 6, 9 minus 6. So let's go ahead and figure this out. On the top, what's 16 minus 10?
6.
On the bottom, what's 9 minus 6?
3.
Can 6 over 3 be simplified?
Yes.
To what?
2.
All right, number 8. We need an x1 and a y1. Pick any points you want.
Negative 3, negative 7.
All right, x1, y1. Another one?
1 and negative 9.
x2, y2. Let's solve it out again. We're going to jump right into the substitution. So what's y2? So put that in parentheses. Minus, what's y1?
7.
On the bottom, what's x2?
1.
And what's x1?
Negative 3.
So what is negative 9 minus 7 more?
Negative 2. Wait.
Verify.
Negative.
Thank you, negative 16. On the bottom, what's 1 minus negative 3?
4.
Can negative 16 divided by positive 4 be simplified?
Yes.
To what?
4. Negative 4.
Negative 4. Now there's also another way to check. And that's the last thing I'm going to show you. You want to know if we have these points, if you were to graph them, or even just by looking at them, would they make a straight line? You could waste your time graphing them, or we can try this next little trick to find the constant rate of change. So let's look at the y's. How do you go from 11 to 15?
Plus 4.
Plus 4. How about from 15 to 23?
Plus 8.
Plus 8. On the x side, how would you go from 2 to 4?
Plus 2.
Plus 2. How about from 4 to 8?
Plus 4.
Plus 4. Now let's compare the way they changed in the first jump. In the first jump, the y changes by plus 4. How did we change in the x in that first jump?
Plus 2.
Plus 2. What's 4 over 2?
2.
2. Keep that number in mind. So in our second jump. In our second jump, how much did we increase or change by?
4.
4.
8. We went up by 8 from 15 to 23, what's up by 8? How about from 4 to 8 over here? Whoops, let me move that whole thing. 4. What's 8 over 4?
2.
Do we get the same matching number?
Yes.
So then, yes, these would be a linear function. Now let's look at a counterexample. So I'm sure you know what this is going to end up being if it's a counterexample. How do you go from 6 to 3?
Minus 3.
Minus 3. How about from 3 to negative 3?
Minus
Negative 6.
Cool. How about from negative 2 to negative 5?
Negative 3.
And how about from negative 5 to negative 8?
Negative 3.
Let's compare those jumps. Our first jump on the y column is at negative 3. And our first jump in the x column is also at negative 3.
1.
That gives us a ratio of 1. Now let's do the second one. Our second jump is at negative 6 compared to negative 3. What's negative 6 divided by negative 3?
Negative 2.
No.
2.
Positive 2. Are they the same number?
No.
So that's not linear. So your assignment for today is here on page 70, what is this, 73? All right, so the top one, we haven't done these, but these are from middle school. You just got to count the rise and the run. Some of the lines are a little faded, but it's not that hard to extrapolate where the missing line pieces are, so you can count a little better. So for example, number 1, to go from the left point to the right point, that's how we read graphs, how much do you have to rise? 1, 2, 3, 4. So that's positive 4 upwards over your run. Positive jumping 1, 2, 3, 4, 5, 6. Can 4, 6 be simplified?
Yes.
To what?
2/3.
So we'll say slope m equals 2/3. Let's look at number 4. We have this straight line. Are there any points on it that have been marked out for us? So let's just pick 2 points. I'll pick one above the x-axis and then one below the x-axis on this line. So let's compare the rise and the run. To go from the bottom point to the top point, how much do I have to go up?
2.
How much do I go sideways?
No, none.
What number is that?
0.
When you have a 0 on the bottom?
0.
Undefined.
Undefined.
Undefined. You can use U and D if you want for undefined. We can be lazy spellers today. Let's look at number 6 then. Do we have any points given to us explicitly on that line?
Yes.
For number 6?
No.
No.
Now, so I'll just go ahead and pick this point to the left and this point to the right. Let's find our slope. To go from the left point to the right point, how many do I go up or down?
2.
To go, I went up 2?
No.
0.
0.
How many do I go to the right?
2.
When you have a 0 on top?
It's undefined.
0,
0.
0 slope. And on the bottom, you have these 6 problems. These just use the slope formula, plug it in, chug out the answer. And the very last 3 are like examples 5 and 6 that we did, where they give you the slope and they give you all but one piece of the coordinates, and you have to work backwards to find that missing one. All right, so that's your lesson for today. Good luck.